Alright, so in these problems we're supposed to find the critical values of the function. So remember, critical values are when the derivative equals 0 or the derivative does not exist. So we have to find out the values that make that true. So first thing we're going to have to do is figure out that derivative. So in this case, I'm going to rewrite this before I try and do the derivative. So we get 4x plus 1 times x squared minus 4 to the 1/2. So in doing the derivative here, we're going to have to use a couple rules. First, product rule. These two things are being multiplied. So I'm going to take the derivative of the first function, which is just 4, times the second function, x squared minus 4 to the 1/2, plus regular first function is 4x plus 1, times derivative of this we have to use chain rule. So bring the 1/2 out in front, times x squared minus 4 to the negative 1/2, so subtract 1 from that exponent, and then multiply by the derivative of the inside, which is 2x. So now I'm going to simplify things a little bit, at least in this part over here. So we've got 4 times x squared minus 4 to the 1/2. I can multiply the 1/2 and the 2x, so we get x times 4x plus 1 times x squared minus 4 to the negative 1/2. Now we want to find out when this is 0 or does not exist. We have to do some stuff we did in the last chapter and factor this out. And I told you last chapter when we did these problems with factoring, there was a reason. The reason is to be able to solve this. So I'm going to factor this out. So the only thing I can really factor here they have in common is the x squared minus 4 to a power. And remember, we can only factor out the smallest exponent. So I'm going to take out an x squared minus 4 to the negative 1/2. And then we can take that out of both terms. So if I take this first term divided by this, the 4 is going to stay out in front. And when I divide these two, I'm subtracting the exponents, and I just get x squared minus 4. When I take this whole term divided by this, then the x squared minus 4 to the negative 1/2 cancel out, and we're just left with an x times 4x plus 1. So I want to go ahead and distribute this and combine some like terms. So we're going to get 4x squared minus 16 plus 4x squared plus x. So derivative f of x equals, I'm going to go ahead and take this and put it in the bottom, so since it's to the negative 1/2. So it's really like square root of x squared minus 4 on the bottom. On top, I'm going to combine those like terms here. We've got 8x squared plus x minus 16. So for this problem, we've got our derivative kind of simplified out. Now, remember, our goal here, what we're trying to do, is find out when is the derivative 0 and when does the derivative not exist. Right? Those are the critical values. So we want to figure out when this is equal to 0, when it would not exist. Well, basically, when we have a expression like this, when we have something in the numerator, something in the denominator, well, whatever makes the numerator equal to 0 is going to give us what makes the derivative 0. So for the derivative of f of x equals 0, I'm just going to set the numerator equal to 0. Right, and solve that. To figure out what's going to make the derivative not exist, well, a couple things here. One would be if we get a negative under the square root, but that's not going to give us something for the function anyway, because if we had a negative under the square root of it here, we'd have one up here too, so that's not going to be part of the domain. The other main thing here is that we can't have the denominator be 0. So square root of x squared minus 4 cannot equal 0. All right, so we're going to figure out when it is equal to 0, and that means the derivative is not going to exist. So we can solve each of these to find our two different types of critical values, where the derivative is 0 and where it does not exist. So for this one, we can just use quadratic formula, or we can graph it. Right? We can graph this and figure out when it's 0. So we have y equals mode. Eight x squared plus x minus 16. And we want to look at that graph. We want to know when is that equal to 0. Well, it looks like we have two different answers. So we can do second trace. We want to calculate the 0 over here. So I'm going to put in -2 for my left bound and -1 for my right bound, and hit enter. So I get -1.478. And we have another one. So I'm going to do second trace again. 0. This time left bound is going to be 1. Right bound is going to be 2. And enter. We get 1.353. Alright, so we get two different answers here. And then we want to figure out when is the derivative, or the denominator, equal to 0. So we can square both sides. X squared minus 4 equals 0. So we should be able to tell that one we're going to get positive or -2. So here are four answers. We have four different critical values. Remember, this one we could use quadratic formula, or we could just graph it and find out when it's 0. Either one should give us the same answer. This one we can solve that way. So when finding the derivative is 0, set the numerator equal to 0, or if it's not a fraction, you set the whole thing equal to 0. And finding when it does not exist, we can set the denominator equal to 0.